In section 5.2, we are reviewing properties of definite integrals. So all of these properties in the box, I think are pretty straightforward. So the constant multiple property, if you have a constant that's like out in front of a function, you can pull that outside and multiply last. And that's really a lot like the distributive property, since the stuff inside of our integral is a sum, and we know we could either distribute it to the sum or we could calculate the sum and then multiply. The sum or difference of integrals, we hinted at this in the section 5.1, that if you have two functions that are inside of an integral, you could break those up and you could integrate one and then add or subtract the other. And that, again, works if your limits of integration are the same. The other thing that we can do is we can break up the limits of integration. So we can add the integral from a to b of f plus b to c is the same as the integral from a to c. And that's something else that we did in section 5.1. And then lastly, this one is maybe the least intuitive, and it's the reversal of limits. So when we are integrating, if I integrate under the curve, and let's say that I'm going from a to b, and so I'm calculating this area under the curve. And let's just say that it is 10. I'm just making up a number. So our integral from a to b of a function, is 10. If we reverse the limits, if we go backwards, so like if we integrate from b to a, that's going to be a negative 10. So if I go from right to left, that is going to cause me to interpret that as a negative 10 instead of a positive. So that's really what this reversal of limits statement is telling us, that if we, instead of going from right to left, if we go from left to right, then we're going to multiply what we get for our integral as by a negative. Okay, so let's try this example using these properties. So we are given some information about the definite integrals of two functions f and g. And so for this first example, we are asked to integrate from 0 to 6 the function f. So if we know that from 0 to 4, that definite integral of f is 5, from 4 to 6 it is 2, that property tells us that we can add those. So we can add this, and then we could add from 4 to 6. And so we get, 5 plus 2? We get 7 for that first example. This next one is an example of the reversal of limits. So if we reverse the limits, this is going to be equal to the negative 1 times the definite integral of f from 4 to 6. So this would just be a negative 2, since we're given that this is 2. From 0 to 6 of 3, if we're integrating the function g of x times 3, so this is an example of that constant multiple rule, that we could pull the 3 out and then multiply that with the definite integral of g from 0 to 6. So since that is 10, this is 3 times 10, which is 30. For the next example, it's a combination of a couple of things. We can pull out that 2. And then actually, as I look, it's also a reversal of limits. So instead of writing that from 0 to 4, I'm going to pull that negative out and hold on. No, I'm not. I'm going to pull the 2 out. So 2 times from 4 to 0 of f of x dx. And then that's going to be the same as negative 2 from 0 to 4. That's what I was trying to write. So Again, the negative is from reversing the limits back to 0 to 4. So that becomes -2 times 5. So we get a -10 for that. All right, this next one just deals with subtraction. And so, well, there's, I guess, a few things going on. So we know we can pull the 2 out. And so 2 times the definite integral from 0 to 6 of f of x. Well, we did that part, the definite integral of 0 to 6 of f of x, in the first example. So we got 7 for that. So this is really like 2 times 7. And then we can subtract from that the definite integral from 0 to 6 of g of x, which is 10. So 14 minus 10, we're left with 4. All right, and then lastly, we've got a constant multiple and a reversal of limits. Oops. So if I pull out the 5, and then if I multiply by a negative, I can change my limits. And since we know from 0 to 6 that definite integral of f is 7, this is -5 times 7, so -35. Okay, so those properties are fairly straightforward. We talked about in section 5.1 that we consider the area under the x-axis. So when we integrate the area under the x-axis, we consider negative. But something we didn't specify in section 5.1 is that's only when we're moving from left to right on the number line. If we move from right to left, that's the same as reversing our limits, and that's going to change the sign of the area. So even though this area under the curve, we said area under the curve is negative, that's when we're moving from left to right. But if I move instead from right to left, so I integrate from B in the direction of A, it's like I'm multiplying that negative of 25 by a -1. And also, if I were to, from right to left, go from A to 0, this +10 would be negative. So if I start at A and I integrate to 0, that's a -10 for that same reason. So generally speaking, area above the curve from left to right is positive. Above the x-axis, area below the x-axis from left to right is negative. When we go from right to left, those both change signs. And that's essentially what we're summarizing in those bullet points. Okay, so the last example, I would say read through this example at the top of page 75, but it refers back to that graph up there. So for this last example, I really want you to pause the video and try this on your own. So first, pause the video and calculate all of the areas. And I'll tell you, when I write my areas, I'm going to write them all as positive numbers, even if they're beneath the axis. And then I'll just remember that they're negative when we calculate these integrals. Okay, so for the semicircle, I got 2 pi r squared divided by 2. That first triangle has an area of 3, 1/2 base times height. The rectangle, 9. The next triangle, 9/2. And then that last triangle that's below the x-axis has an area of 2. So now I'm going to ask you to pause the video again, unless you did this all already, and try to calculate these 6 definite integrals. And then when you're done, just hit play and I'll have the answers and go over them real fast. All right, if you've completed the examples, check your work against mine. So don't forget, in that semicircle, if that whole thing is 2 pi, each quarter sector is just pi. Don't forget, when you go from right to left, everything above the x-axis will be negative and below will be positive when we go from right to left as opposed to left to right. And let me know if you have any questions.